Dear students, let's discuss one of the most common problem you people have asked, that is what is skeletal equation, how to define it correctly, etc. So have a look at definition. Skeletal equation is the simplest representation of a chemical reaction using chemical formulae of the reactants and the products. For example, this is the chemical reaction. Magnesium combines with hydrochloric acid to form magnesium chloride and hydrogen. If we translate it into chemical equation by writing formulae of the reactants and products, then the equation that we'll get will be skeletal equation. Like here, magnesium Mg, because magnesium is a metal and it exists as single atom. Then hydrochloric acid, formula of hydrochloric acid is HCl. Then products, magnesium chloride, formula of magnesium chloride is MgCl2, plus hydrogen H2, because hydrogen doesn't exist in the atomic form like magnesium. Hydrogen being a non-metal, as most of the non-metals do, it exists in the form of molecule with two atoms, so it is H2. And this equation is unbalanced. See here, one magnesium, one hydrogen, two hydrogen, one chlorine, two chlorine. So hydrogen and chlorine atoms are not same both the side, therefore it is an unbalanced equation. Most of the skeletal equations are unbalanced. So see, it's written as well. If you do this definition of the skeletal equation, you can write this in your copy as well, that skeletal equation is the simplest representation of a chemical reaction using chemical formulae of the reactants and the products, and skeletal equations are mostly unbalanced. Now as you people get mostly confused, so I want to say you, all unbalanced equations are skeletal equations, but all skeletal equations are not unbalanced. See here, Cu plus S, Cus. This is an skeletal equation. This is a skeletal equation and this is not unbalanced. Cu plus S, Cus, or Fe plus S, Fes. Now both number of atom of each element are same both the side in this skeletal equation, so it is balanced. Now I hope you understood that skeletal equations are mostly unbalanced is the part of definition, but difference between skeletal and unbalanced equation is that all unbalanced equations are skeletal equations, but all skeletal equations are not unbalanced. Skeletal equations are mostly unbalanced. Let's come to the second problem, which so many of you have asked, is how to find out which valency of element to be taken when the element exhibits more than one valency. The question is about while naming a compound. An example is taken of copper. Children, you know copper has two valencies, 1 and 2. So if a compound of copper is given, suppose it is Cu2O. Now the question is how to understand whether this is cuprous oxide or cupric oxide. Method is simple. Use as you do in mathematics. Suppose let the valency of copper is X. X and no number in mathematics, as you people always do. Now we do formula framing for copper oxide without knowing whether this copper is copper 1 or copper 2, and let's see the result. This is Cu, this is O, and then we write valency of copper to be X, as we don't know, but valency of oxygen we know, which is 2. X may be 1, X may be 2, we'll find out later. Now, after exchanging the valency, the formula will come as Cu2OX. Now, here compare with this formula Cu2O. In this, O is 1 because nothing is written, it means O is 1. So here X should be what? 1. Cu2O1. It means value of X, because if it is Cu2O1, then finally it becomes Cu2O, because 1 we don't mention. It means X is equal to 1 for this compound. So name of this compound will be copper 1 oxide. 1 can be written in bracket as well. We can also say it to be cuprous oxide. Suppose it was not Cu2O, but the compound's formula was CuO. Again we can do in the same way. We let valency of copper, we don't know that what is valency of copper. Okay, it may be whatever, we take it as X. Then CuO, here X, here 2. So finally the formula will become Cu2 and OX. But actually the formula finally that has come is CuO. Now think of what valency or what number can be at the place of X, so that finally the formula becomes CuO. If it is 1, it will become Cu2O1 or Cu2O. But here it has to be CuO. For that, this 2 should get cancelled. When this 2 will get cancelled when X is also 2, because in that case we divide the valencies with the smallest number to the simplest ratio. So what do we do if it is 2? CuO2, 2. We can divide it by the common factor. So finally it will become 1, and then the formula of the compound will become Cu1O1 and finally CuO. It means if we have to find out the valency or the correct name of a compound in which one of the radical, mostly the positive radical, is variably valent, then what do? We frame the formula and put a value of X and then find out what should be the value of X, so that the final formula comes whatever is the real formula of the compound. If we could not understand it, we can take one more example. Let's take example of iron. Suppose iron. Now, if the compound's formula given to you is, suppose, Fe2O3, and you are asked name of the compound, and you want to know whether it is ferrous oxide or ferric oxide, then what to do? Simply we assume valency of iron to be X. Oxygen's valency is the same because oxygen does not show variable valency. Then FeXO2, then after exchanging the valency, the formula will come Fe2OX. Now compare with final formula Fe2O3, here Fe2OX. It means X is 3. If X is 3, it means this is, iron 3 oxide, or we can also say it to be ferric oxide. And if name of the compound is given, then there is no problem. By name only we will understand whether it is like, if it is ferrous oxide, it means it is iron 2 oxide. If it is ferric oxide, it means it is iron 3 oxide. Children, in some cases, you see that name is given copper oxide or iron oxide. This is only because that these two, among the copper and iron oxide, their higher valency oxides are so common that we often don't mention the valency, but ideally we should mention the valency either in the form of the Roman numerals or with us or X, so that we understand whether this is of ferrous or ferric or cuprous or cupric. That's all.